Today we'll be discussing Zeno's paradoxes. For the sake of time, I'll only be discussing 4. So let's get started. So Zeno of Elea was a 5th century BC Greek mathematician and philosopher. He created 10 known paradoxes that last to this day, but the actual amount is still unknown. So most of his paradoxes were based off conclusions that contradicted physical intuition and experience, which makes them a lot different from the other conventional paradoxes we see. So Zeno's paradoxes mainly fall into 2 categories: the paradoxes of motion and the paradoxes of plurality. The paradoxes of motion concern the idea that motion is not real or sometimes an illusion. And the paradoxes of plurality reject the idea of pluralism, the different ways or modes of being. So within the paradoxes of motion, he has one famous paradox called the dichotomy paradox. This paradox revolves around the Greek legend Atalanta, who must complete a race of a finite distance in a finite amount of time. To go from the starting line to the finish, she must travel half the distance. Then she must travel half the remaining distance, and so on. Zeno concludes that this process is done an infinite number of times, and no matter how small of a distance she has left, she must travel half the remaining distance. With an infinite number of steps to finish the race, she cannot finish. However, we know that she still can. Therefore, Zeno believes that motion is simply impossible. Another one of Zeno's paradoxes of motion is the Achilles and tortoise paradox. Much of this paradox relates to the concepts of the dichotomy paradox, but the entire scenario is different. So Zeno says that the Greek hero Achilles is in a foot race with the tortoise, but the tortoise has a 100-meter head start. When the race begins and Achilles catches up to the 100-meter head start, or where the tortoise starts, the tortoise has already traveled to its next place ahead. When Achilles reaches the tortoise's next place, the tortoise is already up ahead. Zeno concludes that because of the distance between Achilles and the tortoise is getting smaller and smaller infinitely, Achilles will never catch up to the tortoise. However, we know that both the dichotomy paradox and the Achilles and the tortoise paradox are not true. So, throughout both paradoxes, Zeno asserts that an infinite series of distances will have an infinite sum. However, this is not true, as mathematicians have discovered that an infinite series can have a finite sum if the common ratios of the series are less than 1. In the dichotomy paradox, the common ratio is 1/2, so the distance between the start and finish is actually finite. In the Achilles paradox, the common ratio is also less than 1, so Achilles can catch up to the tortoise as the distance between each object is finite. However, in the dichotomy paradox, the idea of infinite motion under a finite amount of time is still not yet proven using pure mathematics. So another one of Zeno's paradoxes of motion is the arrow paradox. And in this paradox, Zeno claims that motion can only occur when an object changes its position from what it originally occupied. He also states that time is made of moments or incidents and nothing else. Zeno uses the arrow to demonstrate as it apparently is in motion at any instant. He first assumes that the arrow travels no distance during one durationless instant, because there is time for the arrow to travel, or what Zeno describes as changing positions. The arrow is at rest during that instant. The entire time the arrow is in motion, it only contains instants, and within all of them, the arrow is at rest. From this, Zeno concludes that the arrow cannot be moving. But we also know that this is not true. So, when Zeno assumes that no motion occurs during a durationless instant of time, his logic does not make sense, because 0 meters over 0 seconds written mathematically is undefined. Therefore, it is a flaw to assume that no distance is traveled in an instance that the arrow is at rest. The condition of the arrow in motion is dependent on whether the arrow travels any distance over a finite interval, not instant. So, motion is not something that happens in an instant, but occurs over a finite interval of time, which are composed of many instants. So, Zeno has another category of paradoxes called the paradox of plurality. One of the more famous ones is the argument of denseness. So Zeno first asserts that for any definite collection, that there has a finite number of elements. Therefore, if a collection has an infinite number of things, the collection is indefinite. Then he contradicts this when he claims that for any 2 physical objects to be distinct and not one entire object, there must be a third object between them that physically separates them. Then there are 3 objects, but for all 3 objects to be distinct and not one object again, there must be 2 more objects to separate them, and so on and so forth. With this logic, there would be an infinite number of objects that are needed for the existence of a definite collection of objects, contradicting his initial argument. So the solution lies here. Cantor the 19th proved that certain infinities are greater than the others, such as how there are more decimal numbers than whole numbers, despite both having infinite amounts. So when collections are infinite, it is important to compare infinite collections with respect to the number of elements. Therefore, Zeno's reasoning is flawed when he claims that if a collection is definite, there must be a finite number of elements. Also, regarding his contradiction with the two physical objects being distinct, there must be an object in between them. Objects are rendered distinct if they have different properties, not if they have another object separating them. So, through Zeno's paradoxes, Zeno has contributed to the development of logical and mathematical rigor by creating difficult problems that were not solvable until the concepts of continuity and infinity were known. However, Zeno is one of the first mathematicians to deal with the concept of infinity, and through his unconventional ways of thinking, in Latin, reductio ad absurdum, which is to reduce to the absurd, his paradoxes have set many questions on conventional topics and ideas. Many of his paradoxes are still unanswered to this day, such as the relation between infinite motion within a finite amount of time in his dichotomy paradox. We only discussed infinite motion in a finite distance. But these mysteries within mathematics are what Zeno is known for, and are a testament to Zeno's major impact on how mathematicians think and prove the mathematics we see today.